Hello, students. I realized when I went through this lab that it might be a little problematic for some of you. That is, there's some quirky things in terms of where to click, and I just don't want this to be a frustrating activity. So I made a video which I hope will guide you through the process. It also will go through some of the questions that are asked. So if you get frustrated, this can be a way to get through the lab in a way that kind of goes through it and explains a few things, which they do in text, and it is explained, but I thought maybe this might be also helpful. First, I start with this pre-lab, which is to sort of get you acclimated with where to click on things and what they do. Here we have the bottles, which will, or the jars they're calling them, which will have the larvae. These are the pipettes, which we'll use to transfer things. We have our algae, which is like the fertilizer and the food for the larvae, the sea urchin. This is a reverse filtration, which takes out water, kind of used water in the experiment. Here we have the actual embryos, the sea urchins in there, little babies. And they want us to mix it up, so we'll put it here if we have to mix it. And it looks like we're all good. That's a pretty quick checkout. So we'll start our lab and see how things go. First, they want us to view a slide to see what they look like as little babies. And you can, oh, isn't he cute? Look in there, polarized light, non-polarized. I think between the two is just to bring out other details. So after we're done, we go to the slide drawer, take care of that. Now we're going to start our experiment. We're going to get some seawater here. Glug, 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 right from the ocean. How about that? And then we're going to label these so we don't screw up and put the wrong things in there. And then the first question is just about why 8.1, why 7.7. The reason 8.1, that is, of course, seawater. And 7.7 is what would be the worst case scenario in the with the acidification of oceans. That is, carbon dioxide gets in there and makes the pH go down. So we don't want that, I hope. So let's just check. We go over here. We're going to check the pH, put it in there and see what happens. Hopefully it matches 8.1. Yay! Then we're going to do the same thing with this. Wait, what's going on here? I thought we had to do that. See, this is why I like doing the lab. See, there we go. And then they want us to stir it up, so we put that in there, put it over here, and then we're going to add some carbon dioxide because it's, again, this is seawater, right? So how are we going to get it to 7.7? So we're going to add some carbon dioxide. So we bubble carbon dioxide in there, bloop, 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 and now it's 7.7. Carbon dioxide's in there. We're going to bring it out, and then we're going to store the pH there. So again, we added carbon dioxide, bubbled it through, in order for it to get that lower pH. And in fact, that's what we said. When we increased the amount of CO2 in the area, the pH was down, decreased. Yay, we got that right. So far, so good. Now we're going to prepare a slide and put this here. We're going to take some of the goodies and, oops, see, that's what I mean. Take that, and we're going to look at what the fertilizer looks like. This is the algae. Now, you might say, why the heck do we need to look at what algae? Well, this is to sort of know what not to look for. So this is the algae. It's like the fertilizer that the sea urchins will eat, just to say, oh yeah, not much there. So when we're making measurements, we know what the algae looks like, not to confuse it with the little sea urchin babies. So put that there. And now we're gonna, no, I definitely need to do the highlights, sorry. And, whoop, not sure what that was all about. Now we're going to add some fertilizer, some wonderful food for our little sea urchins. And then we are going to add some embryos. Yay! So we're going to take some, put them in there. Going to take some embryos, put them in there. And then we're going to clean these up so we don't get them mixed up. And then we're going to put the experimental embryos and fertilizer into some jars. So label the jars. Okay, and then we're going to take these and put them in there. What am I missing? Oh, gotta mix it up. Bloop, bloop, bloop. That's right, mix it up first, and then we can put them in there. So we come here, mix everything up, the algae, embryos, seawater, and then put them in here, and then we're going to put them on the shaker table. Yay! So we put them on there, shake them up, and leave it there for a while. Now, it's asking which of the jars contain seawater equivalent to the pH today. That would be the 8.1. So that's the seawater, pH. It went straight from the jug into the jars. We didn't bubble anything through it. Great, thank you for a wonderful assistant helping us out. Now we're going to add a little more fertilizer to the containers. These had little critters in them. Remember, there's critters here and critters here. The critters here, of course, weren't being shaken up. So let's turn it off, and we're going to bring these down. And let's test the pH level. Yay! So 7.7. Wait, what? 7.73. Say what? We'll get back to that. So we come over here. Let's test that out. Should be 8.1, and it is. Yay! So, and in reality, we would do every single jar, okay, just to get the actual value, well, an average of them. So let's figure out here. So why did the pH of the 7.7 go up? It was 7.73, okay? So it went from 7.70 to 7.73, so slightly higher. Maybe we forgot to tighten the lids. Well, maybe pH of 8.1, that is true, but what it says, the pH in jars is influenced by atmospheric CO2, meaning the atmosphere of this lab. Turns out that is the answer. And I know that's a little confusing the way they word it. It's really meant to say that over time, the carbon dioxide that we bubbled in will come out and be equal to the carbon dioxide that's in the lab here. So eventually, these will crawl up to 8.1, so 7.73, and so on, kind of creep up to 8.1 eventually. Sorry if that's confusing, but that's what's happening there. It's kind of equivalating back. So we actually then have to drain the water out. So that is, we can get back to a traditional value. And so again, where are the embryos? They're in the jars. Yay! So let's go see what they look like, okay? And we're going to take some out, and we're going to put it there. We're going to get a cover on it, and then we're going to look at it. Yay! Oh, wow, look at that. Nice. And then we're going to make measurements in the second part of the lab. So we're measuring from the tippy here to like kind of the base there. Great. So let's store that, and then we're going to make one with the other, the 8.1. So we'll take this, drop it there, and then put the cover there. And then we're going to see what that looks like. Okay, now you probably didn't notice, but there should be a difference in the length from tippy top to the base. And that's kind of what this is trying to measure, the difference in growth. So let's go here, and then we're going to now drain. Remember how I said the pH has changed? We're going to drain that water out, and that's what's happening here. Suck it out. And, well, wait a minute. Did we lose any larvae? Did we lose any? Actually, no, they're still there. There's just a little bit of water left over. Yay, so they're still there. And then let's go clean this, because let's see why. We need to clean it because we want to make sure that no larvae are going to accidentally go from 7.7 into the other one. Yay, we don't want that to happen. And then let's go ahead and drain the 8.1. So we're basically draining the water out. And let's take it over here, clean it up. Good. And now, let's see, we want to mix that up. And we're going to add fresh solution, which is theoretically the same. And we want to do this. The reason we need to change the water is so that to make sure that the to make sure that the larvae throughout are fed at the same level. So there's no, whoops, what did I do? Oh, everything, yeah, fed at the same level, pH of the cultures, yeah. And then make sure that the waste from there, is taken out. So it was all of the above. All right. Let's go ahead and put them on the shaker table. Shake it up. Yay. And they'll click that on. And then they're going to want us to clean these out. Clean. Yay. We want to clean it up. All right. So that's that. And let's turn it off. Ding. And we're going to bring it down. And what am I missing here? Yeah, sometimes it doesn't want to do that. And then we're going to prepare those slides again to see what it looks like. So we come over here, grab some of that, put it on there, bing, whoops, bing, and then cover. Okay, and then we're going to do another one with the other type of the 8.1. Yeah, thankfully they're giving me that yellow guide because otherwise I wouldn't have a clue. And then we're going to store those slides so that we can measure them later. Hey, so why is it important to do slides for all 6 jars? Well, basically, if we just do a couple, it's like, well, what's happening in the other ones? And we want to make sure we have enough information to make it what's called statistically valid, meaning we have enough data to support our conclusions. Hey, that's right. Okay, and then there we go into the measurements part. So this concludes the lab, and if you do have any other questions, please don't hesitate to reach out. This is a little tricky, and I hope this video can help make it a little more understandable. And again, you can always play it back, slow it down if you need to. Thank you so much.